Welcome to topic on pointers. The topic is pointers. Probably the most difficult topic in C programming, in C language, is pointers. It is a very powerful feature. It is a very powerful feature, and in fact, you can use that feature to crash the systems also. You can use it to your advantage. You can use it to your disadvantage. So it's a very powerful feature. It is something like a sharp knife. You can do many things. Okay, you can cut anything. You can cut anything. So it's a very powerful feature, and the beauty of C language is, or maybe which C language should not do is the power it gives to the pointers. The power it gives to the pointers, the power it gives to the programmers, the power it gives to the programmers in the form of pointers. Using pointers recklessly will result in crash of the entire systems. Crash of the entire systems. It's a powerful feature. It's a powerful feature. It's a powerful feature actually. It's a powerful feature. So most of the modern languages like Java, Python, etc., they avoided pointers. Though Java derived many concepts from the C language, it looks to some extent similar to the C language. Apart from the object-oriented features, it looks similar to the C language, but it avoids pointers because of basically the power of the pointers, the power it gives to the programmers. The power it gives to the programmers. So that is considered as a disadvantage also, the power it gives to the programmers. So in the first session, we'll discuss about introduction to pointers. The basic principle which we follow as far as pointers is concerned is KISS. Keep it simple, stupid. Keep it simple, stupid. Because it's a powerful feature, but it's also tricky. It is also confusing. So always try to keep it simple. Don't try to learn everything about pointers at a time. Try to be clear about the basics. Try to be clear about the basics. So this is essential for pointers, because you may study it once, twice, thrice, but still at some point of time, if you try to do programming using pointers, you get confused. So you should have your basics strong. You should have your basics strong. Maybe you note down some of the basics and you always have it with them. Have it with you. Okay. So that is essential. So introduction to pointers. Introduction to pointers. So what is pointer? What is pointer? A pointer is a variable that contains the address of another variable. A pointer is a variable. No doubt it's also a variable, but it contains the address. It contains the address of another variable. It contains the address of another variable. So usually whenever you write like this, a equal to say 5. What does it mean? Now a is a variable. Here a is a variable that contains the value 5. That contains the value 5. Even if you write a equal to b, what does it mean? That means a is a variable that contains the value of b. That contains the value of b. Okay, a is a variable that contains the value of b. Now, what we are saying, a pointer is a variable. A pointer is a variable that contains the address of another variable. Address of another variable. That means, say something like this. So now a contains the address of the variable b. So if it is the case, then a is a pointer. A is a pointer. So here you can see pointer variable. This is the pointer variable. location of the pointer variable. What pointer variable contains? Pointer variable contains address of variable, address of another variable. So if you go to the address of that variable, then that address contains the value of the variable, So pointer is a variable that contains the address of variable. So you go to the via this one, you go to the address and retrieve the value. So retrieving the value is you can say two-step process here. The first is you have to find the address of the variable, go to that address, and then retrieve the value of the variable. Now you may wonder why we have to do it. What is the purpose here? All these are simple. Why don't we use a equal to 5, a equal to b, something like that? Why? Where is it? Actually, a equal to this is and b, say. So why we have to use it? Actually? What is happening to the address? A equal to and b. So why we have to store the address and why we have to go to we have to take the two-step process of retrieving the value. So if you have simple variables like integers, characters, etc., if you are working with them, actually there is no use of pointers. You need not use pointers. It's better you go with ordinary variables. But only thing is, when you are doing certain things, when you don't know the amount of memory that is required, and if you want to allocate the memory during runtime, then you go with the pointers. We'll see those things later. But for simple variables, it's better you don't use pointers. If you have addition of two numbers, multiplication of two numbers, prime number, etc., you want to determine the prime number, etc., don't use pointers. So normally a variable contains a value, but in case of pointer, it contains the address of that value. The value of pointer is address. So the value of pointer is not some value actually. So a equal to 5 means a value is 5. But here a contains, if it is a pointer, a contains address. So the value of the pointer is address. The address refers to some other location where the actual value is stored. In the previous slide we have seen it. Pointers are less useful to manipulate simple variables like integers, floating point, etc. They are more useful to work with data types which are collection of items. A single pointer can be used to manipulate collection of items. So we can use pointers. To manipulate the contents of the array. In fact, we can store the values in contiguous locations and we can manipulate them without using arrays also. How it has to be done, we'll see in the last module. So that's why a pointer is a very powerful feature. So they are more useful when data is created dynamically. That means during the runtime you want to create the data, and the amount of data varies. And pointers are useful when call by reference parameter parsing technique is used. This also we will discuss later. But the point is we discussed two parameter parsing techniques. We said C supports two parameter parsing techniques: call by value, call by reference. So for all ordinary variables, it is call by value. For pointers, it is call by reference. And how to parse pointers? Manipulate the parameters in the say the function, and then retrieve that modified values in the calling function also. How to do it? We will see later. But pointers support call by reference. That means we don't pass value, we pass address. We don't pass value to a function, we pass addresses. That point you please remember. Pointers and addresses. One of the main components of the computer memory is computer is main memory, which is otherwise called as RAM. Memory can be considered as an array of consecutively numbered or addressed memory cells. Each memory cell is capable of storing 1 byte of data. The memory cells can be manipulated individually or in contiguous groups. So within the computer's memory, every stored data item occupies one or more contiguous memory cells. The number of memory cells required to store the data item depends on the type of the data item. So what is the meaning of this slide? So if you consider memory, definitely memory is the main component of one of the main components of a computer. So if you consider main memory or RAM, so you can view this memory something like this. So these are considered as memory cells. Each cell capable of storing that is this is one cell, this is another cell. Each cell capable of storing 1 byte of information. All these are numbered. Starting from 0. This will be 0. This will be 0, not the value, the address. This will be the 0th address. Next, this will be 1. This will be 1, like this. All these memory cells are numbered. Whenever we are storing the data, so if it is 1 byte of data, then you can store it in one memory cell. If it is 1 byte of data, you can store it in one memory cell. What happens if you have 2 bytes of data? Suppose let us assume that integer occupies 2 bytes. Now how it is stored? Where it is stored? It is stored in consecutive locations. First byte and then second byte. If it is floating point, then 1, 2, 3, 4, assuming it is 4 bytes. So it is stored in these consecutive locations like this. So that's how the memory is allocated. So the every stored data item occupies one or more contiguous memory cells. The number of memory cells required to store data item depends on the type of the data item, whether it is character, say 1 byte, integer, say 2 bytes, float 4 bytes, maybe double 4 bytes, maybe in the case of array, etc. Say 10 locations. So in the consecutive locations it is stored. Generally it is stored like that only. So the advantage of pointer is it can be made to point to starting address of the contiguous bytes. So if the floating point occupies 4 bytes, we do not store 4 addresses because it is stored in consecutive locations, contiguous locations. So you store only the starting address of the first byte only. The content of the contiguous bytes can be manipulated with the help of a pointer. You can easily manipulate them. As a programmer, we need not bother how to access the subsequent memory locations. That means we know the address of the first location. Okay. In the case of basic data types, say integer occupies 2 bytes, float occupies 4 bytes, double also say occupies 4 bytes, or let us assume 8 bytes. So how do you retrieve the data from the subsequent locations? Because we know the address of only first location. How do you retrieve the data from the subsequent location? That we need not bother. That we need not bother actually. That we need not bother. Okay, that we need not bother. So system takes care of it. System takes care of it. Systems takes care of it. We need to know only the starting address. So that's why the array of consecutive memory locations, we store the contents of the array in consecutive memory locations. Then it can be easily manipulated using pointers. It can be easily manipulated using pointers. The address of V's memory location can be determined by the expression and V. If V is the variable, then its address can be found using this expression and of V. That means the address of V. And is the unary operator. Called the address operator. That evaluates the address of its operand. So and is a unary operator. If you want to retrieve the address of any variable, just precede it with ampersand variable name. That represents the address of that variable. Let us suppose that V is an integer variable and PV is a pointer variable. Then in that case, you already know that V can be declared integer V. If it is an integer, if V is an integer type of variable, then you can declare it as int V. An integer value is stored in location represented by V. Pointer variable can be declared as, just look at it. So what we are doing, PV is a pointer. If V is a variable, then we declare it as int V. If PV is a pointer variable, then we declare it as int star PV space star PV. Okay, star PV. That means if it is a pointer variable, while declaring, we have to place star before it. So that indicates it is a pointer variable. It is not an ordinary variable. So this V is an ordinary variable, whereas PV is a pointer variable. So now again, many people get confused here. So this int actually is not the data type of PV. It is the data type to which PV is pointing. That means, say, okay. So this is PV. If this is PV, then if you write integer star PV, it is not the data type of the value that is stored here. It is the data type of the value that is stored here that matters. So this is integer. So the value that is stored here is integer. Now, what is the value that is stored here? What is the value that is stored in PV pointer? Okay, that is independent of any data type. Whether it is integer star PV, float star PV or double star PV, doesn't matter. So within the pointer, what we have to store? What pointer contains? Address. What pointer contains address? Now what is address? What is address? So can it be real number 12.5? No, it cannot be 12.5. So pointer contains a whole number, always contains a whole number, whether it is whether it points to integer, float, doesn't matter. It always contains whole number. This point you remember. So this data type is the data type of the variable to which it is pointing. Data type of the variable to which it is pointing. Here if it is stored, here if you store integer, then it will be int star pv. If you store float here, then it will be float star pv. So this point, please note down. Books doesn't mention it correctly. So this refers to the data type of the variable to which the pointer is pointing. And pointer contains the address. The address is always the whole number. Say 0, 1, 2, 3, 4, 5 like that. Okay. It depends on the system, what is the address length, etc. If PV points to a floating point, then declaration will be float star PV. Whether pointer points to integer or floating point or collection of data items like array, collection of data items also like array, it will always contain address. In case of array, it is the starting address. In fact, in any case, it is starting address. In case of array, it is a starting address. Even float, because it occupies 4 bytes, so it contains the starting address, the address of the starting byte. The address is always a whole number. And we discussed about the address operator, that is ampersand. There is another operator associated with the pointers called as indirection operator. Prefixing it before a variable make the variable a pointer variable, that we have seen. So if you write like this, that means here PV is a pointer variable. PV is pointing to float type. PV doesn't contain float type. PV always contains whole number only. But PV is pointing to float type. In summary, ampersand is the address operator, star is the indirection operator. Star is considered as, apart from it is also multiplication operator, but star is also considered as the indirection operator or the value at address operator. Here you can see the declarations. We may have to declare some variable and then pointer variable, and if you write PV equal to unv, this is the net effect. So what PV is containing? PV contains the address of v, and this vth location contains the value of v. You can just take a snapshot of this one. Snapshot of this slide. The data item represented by v can be accessed by the expression star PV, where star is a unary operator called the indirection operator. How do you retrieve the value of v? So generally we just write v. But if you want to retrieve it using pointer, because pointer is pointing to v, then you have to use star PV. So star PV and v both represent the same data item. You note down that one. Star PV and v both represent the same data item. Next is the address of v can be accessed using undv. The address of v can be accessed using undv. PV represents the same. So PV and v represents the same. What they reference? Address of v. PV and v represent the same. The address of v. Remember, this will not be PV actually. For convenience, I am using pointer, say PV, pointer to v, something like that. It can be simply star x. It will not be PV. P need not precede that variable name. It's not like that. Okay. PV is just a variable name. So you can use star x also. For convenience, we are using it like this. So PV and v represent the same thing and they represent the address. Next, v and star p, star PV. V and star PV represent the same data item and they represent the value of v. They represent the value of v. Another point, when star PV is on the left side, then the address to which it points is accessed. Whereas when it is present on the right side, the value to which it points is accessed. When star PV is on the left side, then the address to which it points is accessed. Whereas when it is present on the right side, the value to which it points is accessed. Again, this is not a new concept actually. We already studied it. So if you write a equal to 5, say, then what does it mean? If you write a equal to 5, so what a is representing, what is done to the a? A is referenced. That means the address of a is retrieved and there 5 is stored. Okay, there 5 is stored. So the address of a is retrieved, there 5 is stored. Now suppose if you write like this, say b equal to a. Now a is on the right side. What is done? A is actually dereferenced, whereas b is referenced. A is dereferenced. That means the address of a is retrieved and the value at that address is also retrieved. The address at a is retrieved and the value at a is that address. Value at that address is also retrieved. So b equal to a. Okay, same is the case. When star PV is on the left side, then the address to which it points is accessed. Whereas when it is present on the right side, the value to which it points is accessed. So it is little tricky. In fact, pointers is little tricky only. So this is one simple example. In fact, we will study more examples as programming part. But for convenience, for sample, so this is a simple program. So v equal to 10, we are declaring star PV, PV equal to unv. That means the address of v is stored in PV. The address of v is stored in PV. And then we are printing the values, printing star PV and v. So what is printed? Is it same or different? We discussed that star PV and v represent the same thing. So same is printed, that is 10 is printed actually. Print out the address of v, PV and v. We want to print, they both represent the same. Now we don't know exactly what is the address because we are not determining it. For v we are assigning 10, but the address we are not assigning. The address we are not assigning. So the address is assigned by the operating system. So the address is assigned by the operating system. So here, whatever may be the address that is assigned, but you get the same value for PV and v, PV and v. For both, you get the same address. So if you are more interested in the pointers, please go through this Understanding Pointers in C. I think now the book is Understanding Pointers in C and C++ by Yashwant Kenetkar. So please go through the book. But again, always follow that KISS principle. So know the basics, try to know the basics. If you want, you can note down exactly that say PV and V are same, star PV and V are same. So you note down those things, and then remember those things. It's because it is always confusing. Use of pointers is always confusing. So you can go through this Understanding Pointers in C. In fact, if you are interested really in pointers, please go through it. So we'll discuss the remaining things in the next session. So don't point to others, always mind yourself. So always mind your own business. Thank you.